In this video, we will be practicing writing complete and net ionic equations. Let me get started here by a quick list of how we're going to do these. We're going to first write the molecular formula, write the molecular equation. Make sure it's balanced and that you have states. Our second thing that we need to keep track of is our complete ionic equation. Again, this will dissociate all species that are dissolved in water Then we will cross out our spectators. And for our net ionic equation, we will rewrite without the spectator ions. Okay, there's our rules. Now, let me choose an equation to start with here. And I'm going to pick sort of a simple one. I like to pick a barium compound. Those are simple. Let's pick barium nitrate. Need to write a little smaller. And I think I will go ahead and let's use a sodium phosphate, 2 aqueous solutions. This is a typical problem, and this is going to be a double replacement. Which will be in the general format of AX plus BY equals AY plus BX. So I'm going to go ahead and draw this right here because I didn't leave enough room after I said I needed to. Do I have my other pen here? Nope. Notice that both my reactants are dissolved in water. And then to do my first product, this will be a solid. I'll talk about that for a moment in a moment. And NaNO3. That's an AQ. And this will have a 3 here, a 2 here, and a 6 here. Okay, so there is my complete molecular equation. Now we are going to dissociate all of our AQs into the cations and anions. So we'll do this as follows. We have barium. There are 3 barium ions. And please notice it is imperative that you have the number, the state, and the charge. Please notice that we have 6 nitrates. Next, for our second reactant, we have 6 sodiums and we have 2 phosphates. So notice that we have 4 species represented in our product side. I'm going to go ahead and put my reactants, my products on this side. So we do not dissociate the precipitate. Our precipitate will be our barium phosphate, and I'll talk about that more in a moment. We do not dissociate that. Next, my second is 6Na plus and 6NO3 minus AQ. Almost done now. We're going to cross off our spectator ions. In this case, we have these sodium ions and the nitrate ions. Finally, we rewrite the net ionic equation, which, if we've done it correctly for a double replacement reaction, will have 4 species represented. Okay, a note here. To determine which species is the precipitate, you need to reference solubility tables. So you'll find a rule that states something like the rule for phosphates will specify barium phosphate is insoluble in H2O, which means it gets a S for precipitate. And that should be it. You've got several of these to practice. Double check your keys. A couple of things to keep track of is if you have a substance like, let's pick calcium chloride, AQ, and just for fun, well, let's just do it like this. I would dissociate this into my calcium ion and 2 chloride ions. Often people say, why isn't this treated like a Brinkelhoff? No. Elemental chlorine is diatomic, as in Cl2. Chloride ion is Cl minus AQ, not elemental diatomic chlorine. So what you need to remember is the coefficients are used to indicate number. Not subscripts. Okay, that should be good.